So we have discussed the SI units, and now we will define SI unit one by one. Now first is 1 meter. Now what is the 1 meter distance? 1 meter distance is distance travelled by light in 1 divided by 299792458 of the second. So now 299792458. This is the meter is the velocity of the light. So 1 divided by 299792458 time will the light travel, and that travel, the distance traveled by the light in this time will be equal to 1 meter. Now second, we have to define 1 kilogram. What is the 1 kilogram mass? 1 kilogram mass is a cylinder which is made up of platinum and iridium. It is placed at Bureau of Weight and Standard at Cbse near Paris, and this mass of the cylinder is a standard mass and it is equal to 1 kilogram. Third, what is the second? The unit of time. So second is the measured. 1 second is duration of a 91926317770 period of oscillation or period of radiation corresponding to the transition from to hyper state to ground state of cesium 133. Once I again it. So what is the 1 second? 1 second is a time for which there are 91926317770 period of radiation corresponding to the transition between two hyperfine states of hyper state to ground state of cesium 133. Now third is your temperature. Fourth is your ampere current. The unit of current is 1 ampere. Now 1 ampere current can be defined as if we are having a 2 wire. The 2 wires are very thin wires, and in each wire 1 ampere current is flowing in the same direction, and they are placed at 1 meter apart. Then the force of attraction between them is 2 into 10 raised to 7 Newton per meter. Then the current in this wire is 1 ampere. So I can redefine it if the current passing through two conductors which are equal and in the same direction in the thin wire placed at 1 meter apart, and if the force of attraction between these two is 2 into 10 raised to 7 Newton per meter, then current flowing in each wire is 1 ampere. Now fifth is your temperature, and unit is 1 Kelvin. Now 1 Kelvin, now the temperature, the triple point temperature of water is 273.16 Kelvin. So we can define the 1 Kelvin temperature is that temperature which is 1 divided by 273.16 of the temperature of triple point of the water. Triple point means at that point water is present in solid, that is ice, liquid, that is water and vapor. So at this temperature, when the water is present in all the three phases, and that temperature is 273.16 Kelvin. So 1 Kelvin is equal to 1 divided by 273.16 times the temperature of triple point of the water. Now next is your 1 candela. One candela, it is the unit of luminosity. It is the luminosity intensity of 1/60,000 meter square arc of a black body in perpendicular to direction at melting point of platinum, and the pressure is 101.3 Newton per meter square. Once I repeat it again. So 1 candela is the unit of luminosity, and 1 candela is unit of luminosity of 1/60,000 meter square arc of a black body in perpendicular direction at melting point of the platinum, and the pressure is 101.3 Newton per meter square. And last definition is for the amount of matter, 1 mole. Now 1 mole unit is, now if we take the case of carbon 6 carbon 12, then in 6 carbon 12 the number of atoms will be the number of one will be equal to the number of moles, which is equal to the mass is 0.12 kilogram. So here we define it. This is for the carbon. Now for any substance, the 1 mole is amount of the substance contained, which contains as many as entities means molecules or atoms, as there are atoms of carbon 6 carbon 12 in 0.12 kilogram. So these are all the 7 fundamental quantities, and we have discussed the definition for all the 73, and for the other supplementary unit for radian, that is for the plane angle, and stadian for the solid angle, I have discussed earlier. Advantage of SI units. In last lecture we have discussed the 7 SI units in different branches of physics. Now that the first advantage is all these fundamental units of SI units are used in all the sectors like physics, chemistry, maths, engineering, and all the different sets. The same unit is used internationally, not only in India, but all around the world. The same units are used. The earlier units, Cbse unit, MKS unit, and FPS units, have no meaning at this time. Now second is the metric system. In metric system, the quantities are in multiple of 10 or division of 10. So it is easier for the calculation. Rather than, it is not a fractional quantity. It is always multiple of 10 or division of 10. So metric system is involved in this case. Now third attachment is there for the derived units. For the derived physical quantities, they are simply either multiplication or division of the fundamental quantity. Suppose we take the example of velocity. Velocity is distance by the time. The L for distance, length, T for time. So it is a division of L and T. So we can express all the derived units or derived quantities in terms of multiple of fundamental units which we have described in the SI unit. The fourth is it is the internationally accepted units, and fifth is it's a absolute units. It is not in the product of multiple of G, means it is nothing concerned with the acceleration of gravity. So these units are absolute units. They are not to be expressed in the product or division of acceleration of due to gravity, that is small g. So these are 5 advantages of SI units over the MKS unit, CGS unit and FPS unit. Now first of all we will take the how to measure the length. Length is a SI unit, and in length the measurement of length may be very small and may be large. The minimum the length is the dimension or the size of nucleus, which is of the 10 raised to minus 15 of the meter, and maximum is the distance of earth from sun or earth from other star, and that is of the order of 10 raised to power 12 or 13 meters. So there is a wide range of measurement of length. So generally we measure the length for the small distances. We use either meter scale. For the meter scale, minimum length is 1 millimeter or 0.1 centimeter. Then we will take the vernier caliper, which we will discuss later, and vernier caliper we can find the minimum distance 0.01 centimeter. If we take the screw gauge, then we can measure the minimum, that is 0.001 centimeter. If we use the microscope depends upon the visible light, and we can measure the distances which are of the wavelength of visible light. The wavelength of visible light varies from 4 to 6 into 10 raised to power minus 7 meter. So we can measure the distance of this order with the help of microscope. Now if we want to measure the distance less than this, then it cannot be done by any optical method. Then we will use an electron microscope. Now as we will study in 12, the electron is a particle, but when electron is moved, it is as a wave, and the wavelength of electron will be of the order of 1 angstrom. So with the help of electron microscope, we can measure the distance of 1 angstrom. 1 angstrom means 10 raised to minus 10 meter. 1 angstrom means that is of the order of 10 raised to minus 10 meter. Now if we want to measure the distance even less than this, then we can use the tunneling electron microscope, and with the help of tunneling electron microscope, we can measure up to 0.6 angstrom or 0.6 into 10 raised to power minus 10 meter. So in this way we can measure the small distances by these apparatuses in the laboratory. Now if we want to find the large distances, which is very large distances, then we will use different method. And if you want to measure very small distances, and the distances of the order of the angstrom, then the simple method we can give the measurement of the molecular distance between the oleic acid. Oleic acid is a lipid, and its molecular distance is of the order of 10 angstrom, and which we can measure with the help of experiment. Now we take a oleic acid and we take 1 cc of oleic acid in a jar or measuring jar. Then we add alcohol to make the volume from 1 cc to 20 cc. So now the solution of oleic acid in alcohol is of 20 cc. In 20 cc, this is 1 cc of the oleic acid. Now we take 1 cc of this solution. Out of 20 cc, we will take 1 cc and make it again 20 cc. So now we take the 1 cc from this solution, which is the 20 cc. We take only 1 cc and we add alcohol so that it becomes 20 cc. So now what will be the concentration of the oleic acid in this liquid? The concentration of this liquid will be equal to 1 divided by 20 divided by 20. That is equal to 1/400. So 1/400 is the concentration of oleic acid now in this solution. Now what we do? We will take a trough and we fill water on it, and we pour lycopodium powder. Lycopodium powder is a very light powder and it will spread all over the surface of the liquid, or that is water. So it will spread on the water surface. Now we have a dropper and we drop this solution drop by drop on this water. So it will spread it. Then if we take let that the V is the volume of one drop, and if we drop n drop, then the total volume of the oleic acid drop will be n into V. Now what will be the concentration? We can find the concentration. Concentration will be equal to n into V multiplied by 1/400, because so we have this a trough and in which water is there, and we pour the lycopodium powder on it. So lycopodium will spread over it. Now we drop this solution one by one drops on it, and we count that there are the n drops are poured on this. Then this n drop will be spread over the surface of the water, and the lycopodium powder will be displaced, and we can measure the area of the oleic acid. Now the film of the oleic acid will form on the surface. Its thickness will be the molecular thickness of the oleic acid, because it will be only one molecule will be on the surface. So all the molecules are on the surface. So what will be the concentration? Concentration is 1/400. N drop, V is the volume of one drop. So this will be the total volume of the liquid or liquid solution. Now what will be the thickness? Thickness of this will be, if we have the area of this film of the oleic acid is capital A, then volume will be equal to area multiplied by the thickness. Now, so we know the area, so thickness can be found out. So thickness will be equal to T will be equal to volume divided by the area. So volume divided by the area. So what will be volume? Volume will be equal to N into V, the volume of the each drop divided by 400 and V divided by A. So this is the concentration or the volume of the NV but 400 is the volume of the oleic acid and divided by the area of the film. Then this will give the thickness. So the thickness will be the size of molecule. And practically it is found that the thickness of this film, which is N into V, which is the volume of the drop divided by 400 into the area of the film, then it comes to be nearly equal to 10 angstrom. So in this way we can find the small distances or molecular distances of the oleic acid by this method also. Now next our problem is the measurement of the large distances. If we want to find the distance from Earth to Sun, Earth to Moon, Earth to any star, then these are very large distances. These large distances cannot be measured by the meter scale or by any tape. We cannot hold it. So it is not possible to measure the large distances, which is order of the 10 raised to 11 and above this meter. Then we have to take an alternate method, and that method is the parallax method. Now what do you mean by the parallax method? Now suppose we hold our finger or pen before our face, and now I close left eye and see. Then I close the left eye and open the right eye. Then the position of this pencil or this pen on the wall will change, and this shift in change is known as the basis. So this is the point, and these are the 2 points, which is the left eye and this is right eye. So this distance from the left eye to right eye, that is known as the base. And this angle subtended by the thing, this angle is known as the theta. So theta angle is known as the parallax angle, and the distance between left eye and right eye is known as the base. So since angle is small, so angle is equal to arc bata radius. So angle theta is arc is b divided by the radius. Radius is this distance d. So angle is equal to b divided by d, or d will be this distance d will be equal to b by theta. So if we measure the theta should be in radian, b is in meter, then we will get the distance between this point and eyes will be capital D. So capital D will be equal to b bata 3. Suppose we want to find the distance of sun from earth. Now we take one position here. This is our one position, and we look towards a fixed star. The position of star doesn't change, and we take the observation of that fixed star. That fixed star will not move. This will be stationary. So, and then we move it to look at the sun. Then this angle will be formed. This angle is suppose phi 1. Then we move a distance AB. It will be 100 meter, 200 meter distance. And from this point, again, we first look about the star, same star, and find the angle with the sun. This angle is phi 2. So, alternate angles will be equal. This will be equal to phi 2. This will be equal to phi 1. So, total angle phi 1 plus phi 2 is theta, and this will be parallax angle. So now parallel angle for the sun is theta and the basis is B. So we know the B is the distance, we know it, and we find theta 1 and theta phi 1 and phi 2, and total angle is theta. We have measured it and we will substitute and we can find the distance. So angle is equal to arc divided by radius. So this theta will be equal to AB divided by D. So D will be equal to AB divided by theta. So AB we have measured it by the tape, and theta 1 and theta phi 1 and phi 2 or total theta angle, that is parallel measured. So we will just put in this equation. So SA or SB, these are the distance of sun from the earth, will be equal to the basis AB divided by theta. So in this way we can find the angle first, that is a parallel angle, and then we find the distance B and we put in the formula distance AB divided by theta, and that will be distance of sun from the earth. If we want to find the distance of moon, then instead of sun we will focus it on the moon, and with the same method we can find the distance of moon from the earth. Now second problem, we have to find the diameter of moon. We can have the same method, and by the same method we can find, that is the parallel method is used, and we can find or determine the diameter of moon. So suppose this is the moon and this is the earth. We are at here at this point, any point is here. Now we will take the observation of the one end of the moon, that is A, and another side of this is B, from this same point. So we will measure the angle of parallax from the same point. Not in the case of when we find the distance, then we take the 2 points on the earth. Now we will not take 2 points, we will take the observations from E and find the angle of parallax angle in the same way as we have done earlier. So we can find the, we know the distance of moon from the earth, that distance is capital D. So EA is capital D or BE is capital D, theta is the angle. So, and this is the basis. So we can find the basis, this diameter. So if D is the distance between earth and moon and theta is the parallax angle, then the distance from A and B will be the diameter of the moon. So the angle theta will be equal to RAB divided by the radius capital R. So AB will be equal to capital D into theta. So here capital D is the distance of moon from the earth and theta is the parallel angle which is found for the two extreme end of the moon. So here theta will put in the radians and we can find the diameter of moon very easily on the earth. Now we have to convert the angle into radian. How to convert the angle in this? As we know that 180 degree angle is equal to pi radian. So what will be the 1 degree? 1 degree will be equal to pi bata 180. So 1 degree, we write 1 and 0 over here. This is 1 degree. This is equal to pi bata 180. Pi is 3.14. We divide 1 by 80 and it is equal to 1.745 into 10 raised to minus 2 radian. So 1 degree angle is equal to 1.745 into 10 raised to minus 2 angstrom radian. Now if we want to find the 1 minute, so in degree in 1 degree there are 60 minutes. So 1 minute will be equal to 1 degree divided by 60. So 1 minute, so we will write 1 and 1 dash. There is standard symbol for the 1 minute. So 1 minute, 1 dash, this will be equal to 1.745 into 10 raised to minus 6. This is the value of 1 degree divided by 60. So it will be equal to 2.908 into 10 raised to minus 14 radian. So we have converted 1 minute, which is equal to 2.908 into 10 raised to minus 4 radian. Now we can convert 1 second. So there are 60 seconds in 1 minute. So 1 second is written as 2 bar. 1 second will be equal to 1 minute divided by 60. The value of 1 minute is 2.908 in 10 raised to minus 4 divided by 60. So it is equal to 4.847 in 10 raised to minus 6, or generally it is taken as 4.85 into 10 raised to power minus 6 radian. So in this way we can convert degree in radian, then minute in radian, and second in the radian, because they are used for the calculation of the distance of the sun from the earth, the diameter of the earth. Now we can also find the distance of moon from the earth by another method also. We will take, now we know that the earth rotates around the axis, and in 6 months one end is replaced by, suppose this is the earth, and at this time suppose it is at A and this is at the B. After 6 months B will be replaced by A and A will be replaced by this. So we will take one observation of the sun or moon from position A. Then after position A, that is the position of our laboratory. Then after 6 months, we will take again the angle from our laboratory of the month, and the sum of these two angles will be equal to angle of parallel action. So first we have phi 1 from the point A, then we find the phi 2 when B is here at point B. So total angle will be equal to phi 1 plus phi 2. This angle is known. And the distance between A will be the diameter of the earth, which is also known. So we can find this distance will be equal to arc over radius. So what will be this angle? Theta will be equal to arc will be equal to your diameter of the earth divided by the radius is distance d. So we can find the distance d will be equal to capital D divided by theta. So we were discussing to find a distance of moon from our laboratory, and for the one time we measure the angle phi 1. After 6 months the angle from this laboratory is phi 2. So the total angle of parallax will be phi 1 plus phi 2. I call it theta. The distance of 2 points means in 6 months the earth will rotate, and so distance this will be equal to AB will be the diameter of the earth. So we can find the distance of moon will be equal to small d will be equal to capital D, which is the basis, and this basis is the diameter of the earth divided by the parallel angle. So in this way we can find the distance of moon, or we can also find the distance of sun from our laboratory. We take one observation or angle, parallax angle today, and second angle will be measured after 6 months, and we can find the total angle and we divide it by the diameter of the earth and we can get the distance of moon from the earth. Now we take the exercise on the same. If the angle of parallax for the moon is 1 degree 54 minutes, so we will convert it and it will be equal to 60 plus 54, that is 114 minutes. Now the diameter of earth, we know that it is 1.276 into 10 raised to 7 meter. We know it. So now distance of moon will be equal to the diameter d, that is 1.276 into 10 raised to 7 divided by the angle. The angle is 114 minutes. So we will add 60, then it will be in second, and 1 second is equal to 4.85. 4.85 into 10 raised to minus 6, and we calculate it and it will be equal to 3.84 into 10 raised to 8 meter. So we can find the distance of moon from the earth by knowing the parallax angle and diameter of the earth. Now we take the second example. Now if the angular diameter of sun is given and it is equal to 1920 second. This is the angular diameter. Angular diameter means the angle, that is the parallax angle. One and the same thing. Angular diameter means the angle subtended by the diameter. So that is your parallax angle. And capital D, the distance between sun and earth is given. It is equal to 1.496 into 10 raised to 11 meters. So now we have to find the P, the diameter of the sun. So diameter of sun will be B. This theta is known. The distance D is known. So B will be equal to theta into D. So the distance, the diameter of the sun will be equal to B, which will equal to the basis is equal to the distance of sun and earth multiplied the angle of parallax. So D is equal to 1.496 into 10 raised to 11 multiplied by 1920, that is in second. So now we convert into the radian multiplied by 4.85 into 10 raised to minus 6. So this will be the, we calculate it, and this will be the diameter of sun will be equal to 1.39 into 10 raised to 9 meter. So in this way we can find the diameter of the sun by knowing the angular diameter and distance from the sun. Now what are the larger units for the length? Now the distance of sun, moon, earth, galaxies, they are very large distances. Then these large distances we are having a different unit than meter. Then one is the astronomical unit, AU. Astronomical unit is it is the distance between earth and sun. Astronomical distance is the distance between the earth and sun, or we can say it is the mean distance of between earth and sun, because the distance between the earth and sun varies from places to places. So it will be equal to 1.49 into 10 raised to 11 meter. So this distance is known as the one astronomical distance. Then second is the 1 light year. 1 light, L-Y. Light year. Light year is also unit of
Distance.
distance. It is not the unit of time. Light year means the distance traveled by the light in 1 year. It is the total distance traveled by light in 1 year is known as the light year, and it is equal to 9.46 into 10 raised to 15 meter. So this distance is larger than atomic astronomical unit. Then third is the parsec. Now what is meant by parsec? Suppose this is your earth, this is your sun. The distance between sun and earth is 1 astronomical unit, 1 AU. If it is the distance from earth and sun with arc is of the 1 angstrom unit, and the angle subtend is 1 minute, 1 second. This distance is 1 second. Then this distance is parsec. This distance will be the parsec of this point S. From earth, we can take either from the earth or from the sun. So 1 parsec is equal to arc bata radius. So this distance will be equal to arc is your 1 angstrom unit, angle is theta 1 minute, so it is equal to 1.496 into 10 raised to 11 divided by 1 second is equal to 4.85 into 10 raised to power minus 6. We calculate it, and this will be equal to 3.08 into 10 raised to 16 meter. So this is the largest unit of the measurement of distances. So for the large units for the measure of length are either we can the astronomical unit, we can a light year unit, or we can have the person. So these are the large units for the measurement of length for the astronomical objects. This we cannot use for the distances commonly on our earth. So because that distances will be always, these distances are always more than the diameter of the earth. So these distances units are used for the distances for the different objects, and these objects are natural objects, either sun, moon, galaxy. We can say that we can find the distance between Earth and Mars, Earth and Saturn. So all are possible, and they are always in the terms of either it is the atomic mass unit, astronomical unit, or it is light year, or in terms of the parsec.